This part will give you free marks. Yes, you heard that right. This block chemistry questions will give you free marks if you know the reactions. Right? So let's start with the first question. Read the following questions and answer as per the direction given below. Statement 1. Alkali metals dissolve in liquid ammonia to give blue solutions. Okay, they are asking for alkali metals. This is from S block elements. Okay, the statement 2 is alkali metal in liquid ammonia gives solvated species of the type M, NH3, N plus. Okay, so M belongs to alkali metal. So out of these two statements, which is right? Here we have the options also. Both are right or both are wrong. You can take any alkali metal. I would like to take sodium. Okay, sodium plus with solvated ammonia. This will give you amine complex, isn't it? So along with that, some amount of ammonia will also get released. So this is what the reaction happened over there with ammonia-added electrons. Okay, alkali metals dissolve in liquid ammonia to give deep blue solutions which are conducting in nature, right? So the statement is true. Then the blue color, why that is happening? Because of the ammoniated electrons which absorbs energy in the visible region of light, right? So it is showing us a blue color. Okay, then the statement 2. It describes the solvated cations. It can be of anions, it can be of cations. Okay, here they have mentioned only cations, positively charged species, whereas the color is due to the solvated electrons, right? So do note here, however, both the statements are accurate. So we have to pick out the option. Statement 1 is true, statement 2 is true, but statement 2 is not the correct explanation for the statement 1. The blue solution is because of it is observing the light in the visible region. Okay. Then moving on to the next question. The total number of compounds having at least one bridging oxo group among the following complexes. Okay, molecules. N2O3, N2O5, P4O6. Okay, they have given around 8 molecules. You have to know about the structure. Ma'am, how I will know about the structure? By practice only you will get it. Okay, so let's see one by one. N2O3. NO2 we know. So N2O3, just that oxygen is acting as a bridge. So here that is having one bridging oxygen. Then let's move on to N2O5. N2O5, once again, that is also having an oxygen as a bridging compound, bridging element. This is N2O5. Then P4O6. P4O6, what is the structure? It's a giant, some kind of ring, right? So here I'm having oxygen, and these are linked by the oxygens. So POP bond is there. Okay. Then moving on to the next one, what that is? P4O7. So P4O7, which is similar to this, but here that will have a double bond O. That is the only difference for P4O7. Okay. Then the next one, that is H4P2O5. H4P2O5. So where that will have POP bond and double bond OH, OH, H, double bond O. Okay, H4. Okay, here I'm having another H. So H4P2O5. So this is having the POP bond as well. Then if I'm talking about H5P3O10, right? So which is very similar to the previous structure, that is having POP bond. How many phosphorus? 3 phosphorus. And how many oxygens? 10 oxygen So all are in the form of OH. Okay, is it sorted? 1, 2, 3, 4. Missed one more. Okay, 5. So HF5P3O10. Here that is having another oxygen. And the next one, that is H2S2O3, which is having a structure of S double bond S, double bond O, OH and OH. Okay, here the oxygen is not acting as a bridging element. Then the last one, H2S2O5, where the structure is having S double bond O, S is bonded with another S double bond O, OH, OH. Okay, so out of the given complexes, given molecules, which are all having the at least one bridging oxo compound. So the first one, 1, 2, 3, 4, 5, 6. So answer to this question is 6. Okay. Moving on to the next question. Based on the compounds of the group 15 elements, the correct statement are. Okay. So group 15 elements, you have to know about the structure, how it is behaving also. The first statement is that Bi2O5 is more basic than N2O5. Okay. So what will happen as we moving down the group? The metallic nature of the atom increases, right? Moving down the group, metallic nature increases. Hence, the basic nature of the oxide will also get increased. Correct. So the given statement is true. We are comparing bismuth and nitrogen. So this is true. And NF3 is more covalent than BF3. Once again, metallic nature will increase if we are moving down the group. So what will happen? The ionic character will increase. So this, from this, what we can say? Which means NF3 is more covalent comparing to BF3. If they are asking about ionic nature, then BF3 will have more than NF3. So this statement is also true. Then pH3, phosphine boils at a lower temperature than NH3, ammonia. See, in ammonia, we have a strong intramolecular hydrogen bonding. Correct? Here I am having the hydrogen bonding. So due to that, what will happen? It will increase the boiling point when we are compared it with phosphorus, I mean the phosphine. Okay, so this statement is also true. Option D, the N bond N single bond is stronger than PP single bond. Okay, so how we can say that is stronger or weaker? So first of all, here nitrogen is smaller in size than phosphorus. Correct? It is in first period. So this is smaller in size than phosphorus. So what will happen due to the smaller size? Lone pair repulsion. Okay. So while forming N single bond N, it will reduce the overlap of this single bond. The overlapping will get reduced. So N bond N will not be stronger than PP bond. PP bond would be more stronger. So this is not the correct statement. Only the answer become A, B and C. Clear? So moving on to the next question. Among the following, the correct statements are. Okay, trimethyl aluminum has 3 center 2 electron bonds in its dimeric structure. Okay, so trimethyl aluminum. So how it will look like? I'm having 2 aluminum. They're asking about the dimeric. No, so I took 2 aluminum and CH3. Where I should put another CH3. I'm coming to that point. Wait. So here that will have 3 center 2 electron bond. What is that bond? I'm taking CH3 over here. Okay. So 3 center, 1 aluminum, carbon and another aluminum. So 3 center. How many electrons? Only it is having 2 electrons to bond with. So this is forming like a banana. So that's why we are calling this bond as a banana bond. Okay. This works for which compound? B2H6 also. Correct. The dimer of BH3 also. So this side also I'm having a banana bond with another CH3. Okay, this will have 2 electrons only whenever needed. What needed, the 2 electrons will go either this side or this side. Okay, then Lewis acidity of BCl3 is greater than that of AlCl3. Okay, BCl3 is stronger Lewis acid. Why? Because of the smaller size of boron, which makes it stronger. So this statement is also right. Then talking about statement C, AlCl3 has a 3-center 2-electron bond in a dimeric structure. See, AlCl3, so which will form Al2Cl6 as a dimer form, right? So how I can write the structure is ClCl, another Al with ClCl. Okay, remaining I'm having 3 Cls, which will be located like this. But this is not following any banana bond. This is forming through 3-center 4-electron bonds. Okay. So these bonds are correspond to chlorine acting as a bridges between 2 aluminum ions in this case. Okay. So this is not a 3-center 2-electron bond. This is 3-center 4-electron bond. Then BH3 has 3-center 2-electron bonds as a dimeric structure. I had already told you. This is true. This will form a similar structure to this trimethyl aluminum also. Okay, A, B, D are right statement. Then consider the following list of reagent acidified potassium dichromate, alkaline KMnO4, copper sulfate, H2O2, hydrogen peroxide, Cl2, ozone, FeCl3, HNO3 and Na2S2O3. The total number of reagent that can oxidize aqueous iodide is. So that is our question. Which can oxidize aqueous iodide? See, these are good oxidizing agents. So the acidified dichromate, copper sulfate, I'm marking it here. So acidified dichromate, copper sulfate, H2O2, Cl2, FeCl3 and ozone, in fact ozone also, and HNO3. Okay, 1, 2, 3, 6 or 7. So these can oxidize iodide, aqueous iodide to iodine. Okay. So the alkaline KMnO4, what will happen to this? So if I'm taking alkaline KMnO4, this oxidize iodide to IO3 minus. Okay. So no, there will be no reaction between aqueous iodide to sodium thiol. In this case, no reaction happens. Okay. So among this, what would be the right answer to this question? If you want the reactions, just put it in the comment. I will give you the reactions. So the answer to this question will become including this 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. Moving on to the next one. Fusion of MnO2 along with KOH and O2 forms W. Electrolytic oxidation of X yields Y. Okay, it is not X, supposed to be W. Okay, so W yields X, and manganese containing ions present in W and X are Y and Z. Okay, the correct statements are, okay, let's see what is the reaction, the fusion of MnO2, what that will give. So MnO2 plus KOH in the presence of oxygen, fusion will happen to give K2MnO4, correct? Along with that water. Fine. So on electrolysis, what is the next step? Electrolytic oxidation of W yields X. So on electrolysis, this will give you KMnO4. So here MnO4 2 minus, it became, after electrolysis, it became MnO4 minus. Okay, plus KOH. Right. Fine. And the manganese containing ions present in W and X, respectively are Y and Z. Cool. So what are the options given over here? Both Y and Z are colored and have tetrahedral shape. So this is W and this is X. So W is taken as Y and X is taken as Z. Right? Okay. So the first one, K2MnO4, which is green in color, colored and have tetrahedral shape. Is it colored? And KMnO4, obviously we know that is purple in color. Okay, so KMnO4, that is tetrahedral in shape. MnO4 2- is also tetrahedral in shape, but they are not having same color. Colored and have tetrahedral shape. Okay, so they are colored. So we can, they didn't mention same color. So we can take that as a correct statement. Then in an aqueous acidic solution of Y undergoes the disproportionation reaction to give Z and MnO2. So Y, K2MnO4. So I'm taking that as MnO4 2-. Okay, MnO4 2- is undergoing disproportionation reaction in the presence of aqueous medium. So I'm writing the balanced equation for that to give 2MnO4- plus MnO2 plus H2O. Okay, this is undergoing disproportionation reaction to give Z and MnO2. What is Z? KMnO4. Okay, that statement is also true and MnO2 is formed. Then Y is diamagnetic in nature while Z is paramagnetic. Y is MnO4 2- and that is paramagnetic, and if I'm taking Z, that is MnO4-, that is diamagnetic in nature. So this is right. Y is diamagnetic, Z is paramagnetic. No, just an opposite. So this can't be right. In both Y and Z, pi bonding occurs between p orbitals of oxygen and d orbitals of manganese. Pi bonding is between oxygen. Yes, that is true, right? So answer to this question is A, B and D. Okay, the next question, zinc with hot concentrated H2SO4 producing G plus R plus X, and concentrated NaOH, it is giving T plus Q. G plus H2S and ammonium hydroxide, it is producing Z plus X plus Y. Choose the correct options. Okay, so this is our question. So how to go about this type of question? So zinc plus, so what is the reaction happens over there? Zinc plus hot concentrated H2SO4. That will produce zinc sulfate and SO2 and H2O. So they have mentioned G plus R plus X. So I'm taking this as G. This is a main compound because G is interacting with another one. R plus X. Right. So the second one is zinc plus NaOH gives sodium zincate. Right. So that is mentioned as T and Q. And the third reaction is G plus H2S and ammonium hydroxide. G is ZnSO4 with H2S and ammonium hydroxide. It is producing zinc sulfide and ammonium sulfate and H2O. Okay, so here they have mentioned X and Y. So this is Y and this is X. Fine. So Z as a precipitate. Z as a precipitate. Cool. So what are the options? Z is dirty white in color. ZnS, it is dirty white in color. Always the sulfide compounds will go with a dirty shade, like a grey color, black color, those categories. Zinc sulfide is a dirty white in color. Okay. The second one, that is bond order of Q is 1 and its ground state. Bond order of Q. What is Q first of all? Q is H2. So H2 bond order. So 1 electron totally will become 1 by 2. 2 minus 0 become 1. Okay, that statement is also true. Then R is a V-shaped molecule. What is R? So R is SO2. SO2 is V-shaped one. Right? Then oxidation state of zinc in T is +1. Zinc in T. Okay, here you go 2 plus zinc, I don't know, 2 oxygens minus 4 equal to 0. So X is equal to +4 minus 2, which is +2. So which is not a correct statement. Zinc obviously it will not exhibit +1 state. So this is not a correct statement. So the rest of them A, B, C are right. Then moving on to the next question, the pair of reagents that yield paramagnetic species are. Okay, sodium with excess of ammonia. So what are the reactions happening over here? So first of all, sodium with excess of ammonia, let me take a different color, sodium with ammonia, that will produce a complex. The first question we have seen. So that will produce a complex. So Na plus NH3 X plus the ligand has been formed. Okay. Then potassium and excess of O2. K plus O2, that will give KO2. KO2 that is potassium. Which is a paramagnetic species. So O2 is paramagnetic due to the unpaired electrons, right? So which makes the compound paramagnetic, and Cu plus dilute HNO3, which will produce CuNO3 twice, copper nitrate, plus NO, and H2O it will give. So NO here that becomes paramagnetic, correct? Because of the unpaired electrons in nitrogen. Then finally, O2 and 2-ethyl anthraquinone. So 2-ethyl anthraquinone. So how the anthraquinone will form? So this will give anthraquinone, and as a byproduct this will produce hydrogen peroxide. Hydrogen peroxide is diamagnetic in nature. So which makes this is not our answer clearly, and C can be our answer, B can be our answer, and of course sodium can also be our answer. So that is A, B, C are our answers. The correct statement about orthoboric acid. What is orthoboric acid first of all? So orthoboric acid, that is H3BO3, isn't it? Okay, it behaves as a weak acid in water due to the self-ionization. Yes, it behaves as a weak acid. There is a Lewis acid also. It accepts a pair of electrons from OH minus ion. Fine. How the reaction goes? Weak acid in water plus water, it will take up and then it will form BOH 4 times minus. Correct? Due to self-ionization. It is taking up the OH minus ion. It is not undergoing any self-ionization. Okay? So this can't be our answer. Then acidity of its aqueous solution increases upon addition of ethylene glycol. Okay, so if I'm adding ethylene glycol, it will form a structure like this. So CH2O bonded with boron and another CH2O. Okay, so this will form a structure like this. Because of this, the acidity will increase. It has a three-dimensional structure due to hydrogen bonding. So it can form a unsymmetrical hydrogen bonds to have a layered structure, not a three-dimensional structure. Then it is a weak electrolyte in water. So that is true. It is a weak electrolyte in water because I have already mentioned that is a weak acid. So B and D are the right statement. Nitrogen containing compound produced in their action of HNO3 with P4O10. Okay, so P4O10 with HNO3, what would be the reaction? So it will react to form N2O5 and HPO3. Isn't it? N2O5 and HPO3. It is a very good reagent to produce N2O5. This N2O5 cannot be obtained by the reaction of P4 and HNO3. So which makes this is not our answer, and this is diamagnetic. So N2O5, it is diamagnetic. It's diamagnetic, O2 minus, and contains one NN bond. So how this will look like is NON, O, double bond O, double bond O with the coordinate another O. So this is not having any NN bond. Reacts with sodium metal producing a brown gas. So N2O5 reacts with sodium to produce NO2. Okay, so this is producing NO2, which is a brown gas, true, and along with that NaNO3, sodium nitrate is formed. Okay, so this is also a right answer. So B and D is the right answer to this question. Concentrated nitric acid upon long standing turns yellow-brown due to the formation of. Okay, so this kind of this is a previous year JEE advanced question only. So don't think like, ma'am, this is a simple one. Yes, it is a simple one, but you have to know the reaction. So what is the reaction happens over there? HNO3 with sunlight, it will produce 4NO2 plus 2H2O plus O2. So NO2 is your answer. This is a comprehension type of question from block chemistry. There are some deposits of nitrates and phosphates on earth crust. Nitrates are more soluble in water. Nitrates are difficult to reduce under the laboratory conditions, but microbes do it easily. Ammonia forms large number of complexes with transition metal ions. Hybridization easily explains the case of sigma donation capability of ammonia and phosphine. Phosphine is a flammable gas and is prepared from white phosphorus. This is a comprehension given. So the question 1 is, among the following which is correct? Phosphates have no biological significance in humans. No, that is not true. Then between nitrates and phosphates are less abundant in earth crust. No, this is also not true. Then comes between nitrates and phosphate, nitrates are less abundant. So if we can see the passage given, nitrates are more soluble in water. So which makes nitrates less abundant on the earth crust. So which makes C as the right answer. Oxidation of nitrates is possible in soil. So nitrate is already in +5 oxidation state. Again, the oxidation would not be possible. So C is your right answer. Then among the following, the correct statement is, they are telling about which is better donor, better electron donor and why. Okay, so if I'm comparing ammonia and phosphine, ammonia is having more bond angle than phosphine. So ammonia bond angle is 106.5. It's not proper tetrahedral. Okay, it's because of the lone pair present there. It's doing the repulsion purpose. Obviously, the lone pair will do the repulsion. So how it happens? Ammonia structure and the lone pair present on the nitrogen atom and a bonded pair of electrons is also there. The decreased bond angle in these hydrates are thoroughly explained by our sp3 hybridization. So in the option they have given yes, that's not true. It is explained by sp3 hybridization becomes less and less distinct with increase in size of the central metal ion. Okay, that is the reason. So answer to this question is option C. And this is more directional, occupies sp3. Right. Then the next question is white phosphorus on reaction with NaOH gives phosphine as one of the products. What kind of reaction this is? Dimerization, disproportionation, condensation or precipitation. So white phosphorus with NaOH and H2O, it will produce NaH2PO4 PO2 with phosphine. As you can see, one phosphorus is there in the reactant side, but in the product side I am having two. Let's compare the oxidation state as well. So if I am comparing it, here the oxidation state is 0. In NaH2PO2, the oxidation state of phosphorus is +1, and in phosphine that is -3. Clearly see this is a disproportionation reaction. Okay. So these are the 3 questions for that passage. Then the second one, upon heating KClO3 in the presence of catalytic amount of MnO2, a gas W is formed. Excess amount of W reacts with white phosphorus to give X. The reaction of X with pure HNO3 gives Y and Z. So this is a cross passage given. This is a comprehension given. So let's see the reaction first and moving on to the question. So KClO3 presence of catalytic amount of MnO2. Okay, so MnO2 upon heating it will form W. What is W? Excess of W reacts with white phosphorus. So in this reaction I got KCl and O2. So I have to name which is W. They have mentioned that excess of amount of W. Obviously the W must be oxygen. So oxygen reacts with white phosphorus to produce X, which will produce P4O10. X with pure HNO3 gives Y and Z. So P4O10 with HNO3 gives N2O5 and HPO3. Okay, so this is producing Y and Z. Let's see the questions. Y and Z are respectively. Y and Z are N2O5 and HPO3. So I can omit this option, and obviously A becomes a right answer. W and X are respectively. W and X. O2 and P4O10. O2 and P4O10. Okay. Option B is right. Cool. So this is the next question. The color of X2 molecules of group 17 elements changes gradually from yellow to violet down the group. This is due to what causes it changes in color from yellow to violet. So this is an MSQ type of question, multiple select answer. So why the color is formed? Because of the energy, right? So the color of X2 molecule in group 17 elements is changing from yellow to violet. This is because of amount of energy required for the excitation of this halogen. Group 17, no, halogens. So halogen atom, if I am considering fluorine to iodine, so the amount of energy required for this excitation is getting decreased. Energy is getting decreased as I am moving down the group. Okay, so if I am considering HOMO-LUMO, highest occupied and lowest unoccupied, HOMO-LUMO gap decreases down the group, and this makes pi and sigma star excitation easier. Right. So the lesser the energy, what will happen? If the energy gap is lesser, what will happen? It can easily go the excitation, right? So the wavelength of the light observed and hence lesser the wavelength of light will be emitted because the energy is getting decreased down the group. Okay, let's come to the options which is correct. So physical state of X2 at room temperature changes. No, that is not the answer. We have discussed decrease in HOMO-LUMO gap down the group. That is correct. Decrease in, this is pi and sigma. Sigma star gap down the group. That is also right. Decrease in ionization energy. No, that is not right. So B and C becomes right answer to this question. In the next one, the reaction of Cl2 gas with cold dilute and hot concentrated NaOH in water gives sodium salts to two different oxo acids of chlorine, P and Q. Cl2 gas reacts with SO2 gas in the presence of charcoal to give the product R. R reacts with white phosphorus to give the compound S. On hydrolysis, S gives an oxo acid of phosphorus, T. Okay, so this is a comprehension type question. So these are the questions. We are going to solve these two questions. They are asking R, S and T, P, Q. So obviously we have to know the reaction first. So cold dilute NaOH and hot concentrated NaOH. Let's see. The first one I am taking how it is forming P and Q. Right. So reaction with cold dilute NaOH. It is producing obviously NaCl and NaOCl and H2O. Okay. So here P is NaOCl. Q, okay, hot concentrated gives sodium sulfate, two different oxo acids, So Q, for that I have to treat it again with, this is cold. Okay, I'm treating it with hot now. Hot concentrated NaOH, that is producing NaClO3, along with that it is producing NaCl and H2O. That is the difference. You have to know the reaction. There is no other way to go. This is P and Q. Cl2 gas reacts with SO2 gas, presence of charcoal. So Cl2 with SO2, presence of charcoal, it is giving R. So what that will give? It is producing thionyl chloride, SO2Cl2. Okay, that is my R. Then R reacts with white phosphorus to give compound S. So R is reacting with SO2Cl2 is reacting with white phosphorus to give the compound S. On hydrolysis of S gives an oxo acid of phosphorus, T. So R reacts with phosphorus to produce PCl3, that is my S. S is undergoing hydrolysis to produce H3PO3. Okay, so this is another oxo acid of phosphorus, that is T. Okay, let's solve the question. R, S and T respectively are. R is thionyl chloride, T is PCl3 and T becomes H3PO3. Okay, and P and Q. What is P and Q? Respectively are the sodium salt of. The P1 is NaOCl and Q is NaClO3. So, which is hypochlorous and chloric acids. Right? Hypochlorous and chloric acids. This is OClO3 minus and this is OCl minus. Cool. Then the next one, bleaching powder and bleach solution are produced on a large scale and used in several household products. The effectiveness of bleach solution is often measured by iodometry. Bleaching powder contains a salt of oxo acid as one of its component. The anhydride of that oxo acid is. Okay, so what is the formula for bleaching powder? So bleaching powder is nothing but CaOClCl. Okay, so it contains OCl minus and Cl minus. Cool. So the anhydride of the oxo acid is. Here I am taking the oxo acid HOCl. This is the oxo acid. So by removing water, what that will produce? OH from one side, H from another side. Remaining I will left out with one oxygen and 2 Cl, that is Cl2O. Correct? This is an anhydride of hypochlorous acid. Cl2O. Option E. Okay. So 25 ml of bleach solution was mixed with 30 ml of 0.5 molar potassium iodide and 10 ml of 4 normal acetic acid. In the titration of the liberated iodine, 48 ml of 0.25 normal sodium thio was used to reach the end point. The molarity of the household bleach is. Okay. Question maybe looks bit tougher, but let us work out. Okay. So they are telling 30 ml of Ki, 10 ml of 4 normal acetic acid and 0.25 ml of thio. Okay, so I have to work on it. So first Ki iodide is used to produce KCl, right? And what is this question? So in the titration of liberated iodide, thio is used mixed with Ki, okay, and 4 normal of acetic acid. 4 normal of acetic acid. Okay, acetic acid with the bleaching powder that will give CH3COO twice calcium plus H2O. Okay, so the liberated iodide, that is iodometry. Iodometry means the liberation of iodine will happen. So treated with, titrated against with thio. So Na(S2O3) with I2 produces Na2S4O6 plus NaI. So I'm just balancing the equation. 2. Okay, sorted. So this is 2. Okay. Fine. This is first one, second one, and this is third one. Right. So 1 millimole of bleaching powder gives 1 millimole of iodine. Right? Cl2 with iodo, 1 millimole of iodine. Okay, that is in 1:1 ratio. So which is equal to the thio used is 2. So I can write it as 1 millimole of CaOCl2, which is equal to 1 millimole of iodine, which is equal to half millimole of thio. Right? So how I can derive the millimoles of bleaching solution, which is thio normal is given 0.25, 48 ml. So half of 48 ml, because that is what given as the how that much amount is used for the end point. So that's why I pick out thio. So 48.25 normal, which is 6 millimole of bleach solution is used. So they are asking for the molarity of household bleach. So 6 millimole. So molarity into volume to give total 6 millimole. So how much volume? 25 ml of household. So 25 divided by, okay, no, which is where I can get m is equal to 6 by 25, which is equal to 0.24 molar. So 0.24 is your answer. Para-amino N, dimethyl aniline is added to the strongly acidic solution of X. The resulting solution is treated with few drops of aqueous solution of Y to yield a blue coloration due to the formation of methylene blue. Treatment of aqueous solution of Y with the reagent potassium hexacyanoferrate leads to the formation of intense blue precipitate. The precipitate dissolves on excess addition of reagent. Similarly, the treatment of the solution of Y with a solution of potassium hexacyanoferrate leads to the brown coloration due to the formation of Z. They are asking what is X, what is Y, and what is Z. So That is the question. So let's see what is the reaction happening over here. So first, para-amino N, dimethyl aniline is added to strongly acidic solution of X. The resulting solution is treated with few drops of aqueous solution of Y. Okay, so let me take the structure, which is para-amino N, dimethyl aniline. Okay, is added to the strongly acidic solution to produce X. So it is treated with H2S. The resulting solution is treated with a few drops of aqueous solution of Y. It is giving us the blue color. It is forming methylene blue. So that is the clue point over here. So we just added the acidic solution in the beginning, that is H2S, and finally the methylene blue is formed. What is methylene blue? You can see. So methylene blue, which will have a structure like this, sulfide. That's why I took H2S. So here also, this is the structure of methylene blue. Okay. So methylene blue, the treatment of aqueous solution of Y. So Y here, that is FeCl3. Okay, aqueous solution of Y. The reagent is potassium hexacyanoferrate. So obviously FeCl3. Reagent leads to the formation of intense blue precipitate. Okay, the precipitate dissolves in excess addition of the reagent. Okay, so it is forming methylene blue, and followed by, I'm taking potassium ferrocyanate. It will form FeCN6. So this part, the excess of the reagent. Similarly, the treatment of Y with a solution of potassium hexaferrate, brown coloration. So Z becomes FeCN6. So that is our Z. So X is H2S is not given. Okay, so which means that sulfide must be there. So Na2S. So Na2 H2S gas is produced when we are heating the solution of Na2S. Right, so that is X. The compound Y is, that is our ferric chloride. Then compound Z, ferrocyanate. Okay. Then the last question, the noble gases have closed shell electronic configuration and are monoatomic gases under normal condition. The low boiling point of the lighter noble gases are due to weak dispersion forces between the atoms and the absence of the other interatomic interactions. The direct reaction of xenon with fluorine leads to a series of compounds with oxidation number +2, +4 and +6. XeF4 reacts violently with water to give XeO3. The compounds of xenon exhibit rich stereochemistry and their geometries can be deduced considering the total number of electron pairs in the valence shell. So the question is, argon is used in the arc welding because of its. So this is from inert gas group, 18th group. Argon is being inert and creates a inert atmosphere to prevent the oxidation of metal by O2. That's why we are using in the arc welding. So answer to this question is A, low reactivity of the metal, and the structure of XeO3. So 8 plus 6 into 3, 18. So which will become 26 divided by 8. We already know this method. I already told you so many times about this method, which is 3 bond pair and remaining 2, which is 1 lone pair. So total 4. So the structure is Xe with 3 bond pairs and 1 lone pair. Correct? This is an sp3 geometry, sp3 hybridization, and the geometry is trigonal pyramidal. Okay, that's it. So these are the questions are asked in the previous year papers, and some of the questions are we are expecting this year they can ask. Okay, so please look on more and more questions. Please start solving, practicing more and more questions. Let me know if you need any other chapters to be revised or any other questions to be discussed. Okay, thank you.